Welcome to a tutorial on Twine. So we've previously learned how lambdas can be incredibly powerful within Harlowe. They allow us to search different data structures and affect different data structures in a different way by building a complex condition for what we're looking for. So in this example, let's look at how we can use lambdas to manage inventory in a particular way. Now I'm going to do something a little bit different and I'm going to just play this story and then we're going to talk about how it works because how it seems to work and how it actually works is a little different. So let's go ahead and build and play. And we'll see something we've seen in previous examples. We're going to click on a link. It's going to open a little window here using a float box. And we see word wooden sword plus 10, iron sword plus 15. And this seems very straightforward. Perhaps these were just text that appeared in this passage and then we close it back again. Well, what's the appearance of what's actually happening is vastly different. Behind the scenes, there's a lot of complexity going on. And as you might imagine from the name of this video, we're using lambdas to do it. So let's look at first what start does. So start right here just has a float box. So this hook initially has been hidden. Notice a little parentheses instead of a greater than. It contains inside of it a float box, which inside of that is displaying show inventory, which is another passage. Then we're looking at controls, which is open inventory right here, hide controls, show window, and then we're enchanting all of that as a solid background or a solid border, a background of gray, color of white, and a corner radius of 8 using an enchantment for that. Now, the way this is looking is first we start with here and this opens inventory. So this will show the float box and then hide the controls, and then inside show inventory, which we'll look at here in a moment, we'll see the inverse of this. So this is what this is how this is working right here. So let's go over to variables first. So we want to kind of set everything up. So variables has the startup tag, which means it's going to run first. And as a quick review, there are various important tags within Harlowe, startup being one of them, footer and header are two other ones. And here, startup will run before the starting passage. And in fact, any passage with the startup tag will run in alphabetical order before the starting passage. So we have the startup tag. We are collapsing all of this white space right here. We're setting up inventory to be an array containing wooden sword and iron sword, which is what we saw from the show inventory option. And then we're setting up something a little bit interesting right here. So because we're collapsing white space, I evened this out. I put some extra spaces so we could really see what I was doing. Weapons is equal to a data map. And remember, a data map allows us to map kind of string values or a string value to something else. And so I have a string value to another data map. So wooden sword to a data map containing damage, iron sword to a data map containing damage, and 15. And this is particularly important because these all need to match up for a reason why we'll see here in a little bit. Then I'm setting current weapon to inventory's first one. So wooden sword is the first current weapon in the inventory. So these are all set up before anything else. And in fact, we didn't see these in start. These will be over here in variables. So now let's move over to show inventory. So inventory right here has the hook that start was referring to. I'll pull this back up. So enchant was referring to inner right here, and that's part of show inventory. So all of this minus this last link down here is within this hook. And this hook says for each name and inventory. So remember, we can use these symbols right here to space out an array. So for each name in this array, so go through the entire array, which is just two things, but go through it. Set current weapon to name, then display calculate damage. And we'll go look at calculate damage here in just a moment. And then it says print, and we're using right here for a bulleted list, and then we're using upper first. Remember, we can work with strings because they're another data type, and there are multiple macros dedicated to working with strings within Harlowe. Upper first name, so that will make it capital W for wooden, capital I for iron. Then we're using concatenation across all of these. Remember, concatenation is the adding of strings. It's an operation that exists within Harlowe because it also exists within the parent language of JavaScript. It allows us to glue strings together. We concatenate them, which is an English word. It just means put together. We put things together or running them together. So right here, we're saying create a bulleted list where the first word right here has an uppercase letter, and then in here is string damage. Well, damage is not defined right here in this passage, but we know damage right here is a story-wide variable. So we'll see where damage comes up here in just a moment. And then we see the inverse right here, link rerun that we saw over here in start. So we click open inventory and then it disappears and the float box appears. And then the float box will be closed, which will do the reverse, hide the window, show the controls. So what is calculate damage and what is damage? Well, that's where lambdas are coming into play here. Calculate damage is doing something a little tricky here. So it's saying for whatever the selected weapon is, right here, which will be set over in, sorry, I'll move this down, show inventory. So remember we had show inventory set current weapon. So over here, we're looking at, or selected weapon, right? So selected weapon says find, and this is where the lambda comes into play, weapon, where weapon is current weapon. So we're setting current weapon into here. And then we're spreading these back out again, DM names. So remember when we work with data maps, we have names and we have entries. The names are all the corresponding strings or the keys to get to those key value pairs or name value pairs as Harlowe calls them. So spread out all the names as if it was an array of those names. So find weapon where weapon is current weapon. So look through all of the weapons and find the current weapon. Grab the entry right here, which will be an array. And this says set entry to array selected weapons 1. So this is where things get a little tricky. So we're going through a data map and grabbing a data map entry, but it will end up being an array because of how find and DM names work together here. So we're saying, okay, based on whatever you just found, go back to this, find me the corresponding data map, and then unwrap this array right here. Finally, set damage, this is where that story byte variable, to entries damage. So right here, use the key value pair to access it. So what in the world is all this doing? Well, this is allowing me right here to set up these variables right here. And because of how this code works, then anytime I open the inventory, it's going to look through all the inventory weapons right here. And it's then going to compare them to weapons. And then it's going to go ahead and pull up the damage for each one. And it's going to put it in, using print, the float box so I can see it. Put another way, all I need to do, because of how this works, is add more things to the inventory and then make sure they're correspondingly within weapons right here, and the code will do the rest. It will go through and it will tell me the corresponding damage, plus 10, plus 15, based on the lambda that I wrote in another passage. So it's doing the work of managing this inventory for us by showing us all the corresponding statistical information about those weapons based on the variables I set up. Very complicated example here, but using lambdas and working with our knowledge of multiple macros here, and especially how tags work compared to working with enchantments, all together to create an example so that we can manage inventory. All we would need to do from this point forward is again work with these variables right here. And as long as I'm using show inventory will work with calculate damage, and they will all go through and show the corresponding statistics. Now let's say I wanted to show more than damage. Well, it wouldn't be that much of a change to change it. So right here, it just says show damage to entries, or set damage to entries damage. Conceivably, I could just set up additional story-wide variables as part of calculate damage, and in show inventory, do a very similar print. Just print out each new corresponding line to each new statistical value I was adding as a name entry pair within the variables of weapons. So for example, if I wanted damage, but I also wanted some other statistic here, maybe intellect or something else we were trying to track as part of this weapon, we would just add it as a new data map. We would then update show inventory, and then we would update calculate damage so that we were tracking that story-wide variable, and it would bring the story-wide variable in, show inventory would then print it for us, and it would all work together. So how useful are lambdas when working with a number of different data structures? Incredibly useful. Notice we used find to write code for us. We didn't have to go through all the code. We just said, hey, go get this for us, and then we will unwrap it and show the current value we're interested in. We didn't need to go through each thing in turn, nor did we need to go through multiple arrays in turn. Calculate damage is literally only 3 lines. Go find it, unwrap it, tell me it's damage. And then we pass that information, kind of indirectly using damage, to this other passage that then prints it for us. So incredibly useful ways of using lambdas as ways of searching through data structures, and we've seen other ways to do it. But in this particular example, again, revisiting lots of different concepts, we can really create some complex things relying on lambdas to do things like managing inventory for us, all within Harlowe 3.3. Thanks for watching.